Hi everybody, hope all are doing well today. This is Abdul Halim with another interesting experiment of moving cursor. There will be a bar LED display on our application board, PLC application board 34500. So we are supposed to write a program that will control LED turning on off pattern in a such way that it will reflect our cursor is moving up or down. Briefly, the problem statement will be like this: to write a simple but an efficient ladder logic program in Studio 5000 in order to control LED bar on off time and pattern so that it will resemble a cursor is moving up and down at fixed interval. So if you are ready and you understand the problem statement. About the hardware setup for today's assignment, we have got Compact Logix L30ER from Allen Bradley. It's a PLC controller along with its digital I/O modules 1769 series. Then we also have got PLC application board from Feedback, which is 34500. I have explained about it in my previous videos. And for today's assignment, as we have been asked to write an efficient code in Studio 5000, a ladder logic code, to write these LED bar display in order it to resemble a cursor is moving up and down. So we have to write an efficient code so that these LED bar display will be resembling that or showing that a cursor is moving up and all the way down. So this should continue at fixed constant speed. So let's start with writing a ladder code in Studio 5000. Let's start opening up the Studio 5000. I already opened it, and let's click on new project. Or wait a second, before moving to write a program in Studio 5000, I would like to explain how it's going to work through this table, a sequence table. So viewers, I have summarized everything here in this file, in this document file. There's a table and there are a few points to be to you to consider them or to bring in your mind before writing a program. Viewers, we will be creating an array in Studio 5000 that will be containing 15 elements, and those 15 elements will be having a data which is shown over here in this column, decimal column. The first element will be having 0, then 2, 4, 16, 32 and so on up until 128. Then we will be writing the same value in reverse order. Then the next one is 64, 32, 16, 8, 4, 2 and so on until 1. This data, this array element data, will be written to the digital output module point A to point 7, which will be 1 byte long. So this array data we will be writing to digital output module port first byte, or to first 8 point, which is first byte, I can say. So as you can see, in for first fixed interval, for first few millisecond, we will be turning on point A, and then D, then D1, then D2 and D4, so on until D7. After each fixed interval we will be turning it on, the rest will remain off. And then we will go to our next step, which is a reverse order. We will be sending this reverse order data to the same output points in a reverse order. So this one will reflect that cursor is moving down, and the upper half is reflecting that is data is moving, cursor is moving upside. So just to brief it again, D0 and D0 to D7 of output module are connected to digital LED bar display point A to H, which is located on PLC application board 35400, which I have explained already in my previous lecture. The decimal value which is in this column will be hold a second for okay, I'm back. So I was about to explain point 2. Decimal value will be saved in array. That this column will be read one by one through a sequencer output instruction. We'll be using sequencer output instruction to read this value one by one and to write it to the port. That's all about. So if you are ready, let's start writing our program. Create a new project. This new window will pop up. Give it a name, cursor. Let's say bar cursor, LED bar cursor, LED bar space cursor, bar and space cursor. Click next. No protection, and wait it to populate. Once it's open up, our next step is to hide this window, and next step is to make sure that our Studio-5000 is communicating with our controller, which is not the case. Oh, it is the case. No, it is not. As we can see, path is not set. So let's click on the communication tab, who's active. Yes, we can see I connected you through USB, so refresh it, click on a USB controller, expand it and see, yeah, this is the one. Set the project path, close it, then add IO modules. I'll be adding only one module because this assignment doesn't need any other module to be added. So digital module, output module should be there from Allen Bradley, so let's filter out Allen Bradley only. So OB16 is our module which is connected to slot 4 of the chassis. Slot 4, give it a name, digital out. So give it a digital out space 16 point. This is how I give it a name. And click on connection, set its RPI to 1 millisecond, which is the fastest. It's our requested packet interval RPI time. Click OK. You are ready to go. Okay, so the way I start writing a program, I start with creating a tag. So let's create a tag, which is the first one, our data array. So data array should be 16 element long, so create it. It should be base because it doesn't have to be on controller, so create. Then create data out. So we cannot directly write an array data which is 32 by a bit long, and we are going to write to a port which is only 16 points, so we need to have a 8-bit data which should be written to the directly to the digital output module. So this is 8-bit long, or let's create it, that out. And now we have to create another timer, so create bar timing, give it a name, bar timing. So this should be a timer, yeah, create, and double click on the main routine. You will be having one rung with EE with an error because there is no instruction on it. Let's place sequencer output instruction over here, and also take another rung over here and bring up a timer on. We already created, so let's configure. Where is the timer? I don't see the, oh yeah, bar timing. So bar timer, set it to 100 millisecond, and it should start timing when there is no timing. I mean, yeah, okay. So place one more over here and give it a name. give it a control. Okay, so we already created an array. This data array should be there, and mask should be with by the way, which I'll explain. Hold a second. If anyone from you who are viewers from you, if they don't know about sequencer output instruction, right click over it and click instruction help. It will take you this new window of help. Help window. Here's a very well defined help about the sequencer output. Go through it. You will come to know how to configure it and how to use and how it functions. So after reading, I trust you will be able to use this, and how to configure, you would be able to configure it at your own. Okay, so the destination in our case should be this data, whatever. We will be reading this array on every 100 millisecond. The first element, then second element, and then so on will be read by the sequencer output and will be returned to this data out variable. So let's create a control for it. Let's say bar controller draw bar. Simply ntrl, the simplest one. Create the length, as we know that the array length is 16 elements. So let's place a loop over here, because we have to move it using moving instruction. Move this data array, data output to the port is our digital output module, which is connected to slot 4. So we have chosen that. Okay, so we are done with it. So let's see, is there any error? Yeah, there is no error. So let's click on online and download to the controller. Yeah, download it. Viewers, as you can see, this is the simplest and efficient program, I can say. So let's download and see. Yes, click yes to take it to run mode. As you can see, it is in run mode. I will turn up my other camera, my side camera, to show you the hardware. So this one is running already and program is successfully downloaded. So this is only 3 instruction ladder logic program, which is simplest and efficient. Let's have a look on the output. Okay, so there you go. As you can see here, a cursor is moving up and down at fixed interval, and you can see, if my camera can focus, it is in running mode, and here it is. As you can see, I have connected point A to H to the PLC output module 0 to 7.027 of digital output module. That's all about it. And we will be writing a ladder logic program which will be controlling its speed. We will involve analog IO modules, and hopefully you will enjoy it, and stay tuned. You will see how we will be controlling this cursor moving rate. We could be able to move it, make it faster or slower. So stay tuned for next video lecture. I hope you would have enjoyed it. If so, please don't forget to subscribe and don't forget to click on like button. Thanks for watching. Have a good day.